Right, so now in this video we're going to talk about polygons. So we've already moved from lines to angles to triangles. Now we will focus on polygons. Now this idea is extremely important. I've extracted this information from a grade 10 book. And so if you're thinking ahead, you would realize that this information is going to be important when you reach grade 10. And at grade 8 and grade 9, we do the basic stuff where we just talk about the properties of a shape. But we're going to utilize these properties to get what we call theorems, right? And that's when stuff gets a bit more interesting. But for now, let's just focus on the properties. The properties of a shape is basically what makes the shape up, right? If I were to ask you what are some of your distinct features, that would be the properties that make you up. What defines you is basically the properties of a shape. And once we understand that, when we are given a specific shape, we can utilize its property. Now that's the guiding thing that you need to remember. When you are given the shape, you can utilize its properties. Okay? So how are shapes born? Shapes are all born from polygons, which is a multi-sided figure. Right? Poly meaning many, gon meaning side. Right? Then we move over to a quadrilateral, which is a four-sided figure. From the quadrilateral, under certain conditions, we can make a quadrilateral a trapezium. And from a quadrilateral, under certain conditions, we can make a quadrilateral a kite. From there, under a quadrilateral, a parallelogram is born, right? Which has both pairs of opposite sides parallel and equal, right? We'll get to that when we understand the properties of the shapes. Then from a parallelogram, we have what we call a rhombus and a rectangle. From a rectangle, we get a square, and from a rhombus, we get a square. Now, what this diagram illustrates, it shows you how the shapes are born. So from a quadrilateral, a parallelogram is born. From a parallelogram, a rectangle or a rhombus can be born, right? But that's what we actually learn at a higher level. That's basically theorems when we talk about it from that perspective. But we're just showing you, we're illustrating the interconnectedness with all of these shapes. Can you see that? So that's what we are concerned with. In the above diagram, I explain how each shape develops from the polygon to the quadrilateral, okay, and so on. Once we define the properties of the shapes, remember the properties are the characteristics of the shapes, we can then use either a single property or a group of properties to prove any other shape from any other shape. Now, that's, like I said, grade 10 level stuff. All you need to know is what are the properties. You just need to memorize what the properties of the shapes are. If you're given a square, what are some of the things that makes up a square? Okay, it has a 90-degree angle, opposite sides parallel, all sides are equal, things like that. You just need to be able to mention those things, right? A polygon is a flat 2D enclosed shape with at least 3 straight sides and angles. Okay, so that's what makes a polygon. It's a 2D shape. Remember we said from a point, when you have 2 points, you have a line. And then when you have lines that join together, we have a plane, right? Or an enclosed shape. So this is basically what we are talking about. Quadrilaterals. A quadrilateral is a type of polygon which has 4 sides, 4 vertices, and 4 angles. The sum of the 4 interior angles has to be 360 degrees. So that's the basic definition of a quadrilateral. We then have 6 types of quadrilaterals. So exactly as I mentioned, from the quadrilateral, these 1, 2, 3, 4, 5, 6 shapes are born. Okay, so this is why understanding how they are born and where they come from is so important. Okay, I will list them strategically so that we can make meaningful connections between the shapes. I will list all the properties of the shapes, and you should study these properties because it'll be useful when we discuss other topics. Okay, if given these quadrilaterals, then we can use the properties. Now that's very important. If given these quadrilaterals, then we can use these properties. Exactly as I mentioned, the if and then statement is very important in maths. If and then. If this, then what? So if I'm given a trapezium, then I can use this one too. If I'm given a kite, then I can use all of these properties that come with it. Right? You can basically annotate your diagram with it. Okay? Now the way I'm going to mention and list the properties is in the following way. And this is how you should remember it. Because we have to learn with strategy. We cannot just understand these things and have all of these ideas float in our mind, because then there's no order, right? So the way we're going to do it is we're going to list all the properties involving the sides, then all the properties involving the angles, and then all the properties involving the diagonals. So we're going to go in that way, okay? So the trapezium, a type of quadrilateral with 1 pair of opposite sides parallel. So that's the definition of it. What are the properties? One pair of opposite sides parallel. So you can see I listed the property involving a side. So we take that. What is the area of a trapezium? It is half the sum of the parallel sides. So we add this and this together and we multiply it by the perpendicular height. So that's how we get the area of the trapezium. Okay. And so what I'm saying is, if I am given the shape, I do not know what the shape is, but I'm given the shape and they tell me that it is a trapezium. What can I conclude? I can conclude that the one pairs of opposite sides are parallel. So we can annotate the diagram. And from this, what can we say? We can say that co-interior angles are supplementary. If I extend this line down, this becomes a transversal. Then we can say that corresponding angles are equal. Okay, so there's a lot of things that we can infer just by this word parallel. And I've talked about that under lines and angles. Then we move over to the kite. A kite is a type of quadrilateral with two pairs of adjacent sides equal with diagonals that intersect at right angles. Okay, so that's the basic definition, right? It is a quadrilateral with two pairs of adjacent sides equal. So this adjacent means next to each other. So this here is one pair and this here is another pair. So these sides lie next to each other and they are equal. Okay, and the diagonals intersect at 90 degrees. So that's the intersection point. What's the properties? Okay, what's the properties of a kite? I'll make mention of something very important here. The longer diagonal is generally the diagonal between the equal sides. So let's say you're given some random kite, right? And they tell you that this here, that these here are equal and these here are equal. The longer diagonal will be this diagonal here. That's the definition of it. We say it's the one in between the equal sides. So that's the one in between the equal sides. Okay. The two pairs of adjacent sides are equal. We got that. That and that are equal. Can you see I'm talking about sides? The longer diagonal bisects the shorter diagonal. Now we're talking about diagonals. Right? The longer diagonal bisects the shorter diagonal. So where's the longer diagonal? There's it here. It cuts the shorter diagonal in half. The diagonals intersect at 90 degrees. There it intersects at 90 degrees. The kite is symmetrical about the longer diagonal. So whatever you have on this side will be the same as whatever you have on that side. Right? So then we can talk about congruency. We can bring in congruency. Right? Because they are the same. So you can see it makes sense. This and this is the same. This here and this here is the same. And we have this here to be common. So using side, we can prove this property, or we can validate the property. Again, something talking about the diagonals. There's another one, diagonals. The angles opposite the diagonals are equal. So here's the longer diagonal. The angles opposite the longer diagonal are equal. Right? You need to visualize this and understand these things deeply. And the longer diagonal bisects the opposite angles, these ones here. So it cuts it in half. Okay? So what you need to remember are these words here. Intersect, bisect, and dissect. To intersect means to just cross. They cut each other. To bisect means to cut into two equal halves. Right? So bi, from bicycle, that's where the bi come from, means two. And to dissect means to cut up or cut open and study. Okay? So that's what it means. And then the area of this here is half the product of the diagonals. So I'll take the length of this diagonal. I'll take the length of this diagonal. I'll multiply those lengths together. And then I'll multiply it by half. And that's how I'll get the area of this kite. Right. So you can see we're inside diagonals. Everything is predominantly about the diagonals for the kite. Right. So you need to learn it like that. Very important. Very, very important stuff. Then we move over to the parallelogram. Right? A parallelogram is a quadrilateral with both pairs of opposite sides parallel and equal. Opposite angles are congruent. Adjacent angles are supplementary. And the diagonals bisect each other. So that's like the definition of it. But we're not so concerned about the definition. We're more worried about the properties. So let's go. See, side, angle, diagonal. Let's talk about all of the properties involving the sides of a parallelogram. The opposite sides are parallel. The opposite sides are equal. So if I was given a shape in the exam and they tell me that this shape is a parallelogram, firstly what I can do is I can say that that and that are parallel, that and that are parallel, right? Then I can say that this side here and these sides here are equal, right? Then I can say that the opposite angles are equal. So these angles are equal and these angles are equal. So whatever I get here, I must write it here. So let's say in the paper they say this is a parallelogram. This here is equal to 60 degrees. Calculate the size of angle A. Angle A has to be equal to 60 degrees because the opposite angles of a parallelogram are equal. So if we are given the shape, we can use its properties. Can you see that how powerful this is? And the diagonals of a parallelogram bisect each other. So if this parallelogram had diagonals, then we can say that this length here is equal to that length and these lengths here are equal. So you can see it quite neatly here. Okay? And what's the area of a parallelogram? It's the perpendicular height, this height here, right, multiplied by the length of this base. Okay, that's how we would get a parallelogram. Right, let's take that out. Let's talk about a rectangle. A rectangle is a parallelogram that has 4 angles equal to 90 degrees. Okay, a rectangle thus has all of the properties of a parallelogram. Now, this is where the definitions become important. Listen to this. Listen to this carefully, right? A rectangle is a parallelogram that has 4 angles equal to 90 degrees. It is a parallelogram, therefore all of these properties here can transfer down here, isn't it? Because it is a parallelogram. But the fact that we are giving it a new name means something makes it different, isn't it? That's why we list it out here. We list out the special properties. Remember I said under specific conditions, we can make a parallelogram a rectangle. These are what we are talking about. Because if it was a parallelogram, then we can't call it a rectangle. What makes it different? It comes from the parallelogram, but what makes it different? Can you see that? Right, that's why the diagram is so important. So what we can say, both pairs of opposite sides parallel, both pairs of opposite sides equal, both pairs of opposite angles equal, both diagonals bisect each other. That's straightforward, we copied from there. But what makes it different? What makes it special? The diagonals are equal in length. The length from here to here is the same as the length from here to here. Can you see that? That's what makes it different. In the parallelogram, they didn't say that, right? And all interior angles are equal to 90 degrees. So these angles here equal to 90 degrees. That's not what we can say about a parallelogram. So that's what makes it different. Can you see that? So we're saying that it comes from a parallelogram. A parallelogram makes a rectangle. But what makes it different is the fact that the diagonals are equal and that one angle is equal to 90 degrees. Okay. Then we have a rhombus. A rhombus is a parallelogram with all 4 sides equal. Okay. So a rhombus is a parallelogram. What can we say? If it is a parallelogram, we can take the properties from a parallelogram. Which ones are those? It's the properties that the opposite sides are parallel. So these sides here are parallel. The opposite sides are equal. So these here are all equal, right? The opposite angles are equal. These angles are equal and these angles are equal, right? And the diagonals bisect each other. So that comes from where? From the parallelogram. But what makes it special, right? The fact that it's a rhombus, we gave it a new name, means something has to make it different, isn't it? All sides are equal in length. So we're saying that the opposite sides are equal, right? But now we're saying all sides are equal in length. So we can do that now. All have to be the same, right? The diagonals bisect each other at 90 degrees. So that's special because we said that the diagonals bisect each other for a parallelogram. But here it doesn't just bisect each other. It bisects it at 90 degrees. Okay? And the diagonals bisect both pairs of opposite angles. So see these angles in the corner here. It cuts it in half. Bisect. Cut in half. So all of these angles here, if this was 60, then you can say that this here is 30 and this here is 30. Can you see that? That's what makes it special. Okay. Then we move over to the last polygon, which is a square. See, here we're saying a square is a rhombus with all 4 sides equal. So what can we say? All of the properties of a rhombus can come down here. All of it. All these properties here can come down. Opposite sides equal. Its opposite sides are parallel. Its opposite sides are equal. Its all sides equal in length. The opposite angles are equal. Its diagonals bisect each other. The diagonals bisect each other at 90 degrees. The diagonals bisect both pairs of opposite angles. Right? All of these properties come in. But what makes it different from a rhombus? Right? What makes it different from a rhombus is the fact that all interior angles are equal to 90 degrees. So this here are equal to 90 degrees. The diagonals are equal in length. That's one of it. and the diagonals bisect both pairs of corner angles. So see these corner angles here, it bisects it, it cuts it in half. So if this is 90 degrees, that's just to be 45, 45, 45, 45, and the same will apply for all of these values. So that's what you need to basically remember, right? You remember, the way you remember it, right, you're not actually learning a lot of things. You're basically just learning the parallelogram. Watch here. You're basically just learning the properties of a parallelogram, all of these here, right? And you can see it applies here, even here and here, right? And then you're just going to learn what makes a rectangle different from a parallelogram. So you're just learning two more things. And then you're going to learn what makes a rhombus different from a parallelogram. You're going to learn three more things, right? And then once you learn the properties of a rhombus, right, then you bring it all over here and then you ask yourself, okay, what makes a square different from a rhombus? And then you're going to learn three more things. So you're not actually learning a lot of things when you understand how shapes are born and develop from other shapes. Okay, but like I said, I showed you practically. How would you be tested on these things? You could be given a rhombus like this here, right? And you could be given, let's say, this angle here, 30 degrees. And you would need to find this angle here, x. How would you do this? If it is given to be a rhombus, then I can say that these sides here are parallel. And when I have parallel lines, I can use corresponding angles, alternate angles, or co-interior angles. So that's what we can do. And we can say that x is equal to 30 degrees because of alternate angles. Can you see that? So that's what we are basically doing and how we are building from grade 8 work, right? Because grade 8, we just did lines, angles, and triangles, and we touched a bit on polygons. Now we're getting a bit more in depth with our definitions and so on, right? And again, how do you learn it? You learn the properties according to sides, then angles, and then diagonals. Okay.